Okay, this is math 2, and we're going to do 19 to 22 in this one, and then we're going to do the second video for the other. So just an FYI, this is probably going to be a straight 15-15 for both. So please make sure you time out your, set aside about half an hour for this. Okay, on the first one, Koi is inflating a spherical balloon for her brother's birthday party. She has used 3 full breaths so far, and her balloon is only half the width that she needs. Assuming that she puts in the same amount of air into the balloon with each breath, how many more breaths does she need to finish the task? Explain how you know. So this is actually going to piggyback on the things that we did in class today, especially on the linear scale factor. So realistically, okay, I need you to think about this logically. If you inflate the balloon halfway, if you inflate another half, then you've technically inflated the whole balloon. So you've essentially doubled, right, the balloon size. If you're halfway, if you put another halfway, you've gone this twice the number of on the linear scale factor. Okay, linear factors. So that means if you go to the thing that we did today, if your linear scale factor, this is half a balloon. A balloon. This is the full balloon. 2 L's in there. Okay. So half a balloon, full balloon, the linear scale factor. The surface area, we don't really care about. But what we do know is that the volume is that she took for half a balloon. Volume comes from the breaths. She took 3 of them in order to actually inflate half a balloon. The ratio volumes should be 1 to, it should be a 1 to 8 ratio, or better known as just 1 over 8, but in this case 1 to 8. And the reason is because 1 to 2, right, is the linear scale factor. The surface area ratio should be 1 to 4, so that means your volume ratio is going to be 1 to 2, better known as 2 to the 3rd power. That's how we get the 8. Okay, volume is cubed. So that means if in half a balloon, she took 3 breaths. In order to get this one here, we had to multiply by what the volume of the ratio was. In this case, we're going to multiply by 8. So we're going to get 24 breaths total that she needs to actually make a full balloon. So since she's already actually taken 21 breaths, she has already taken 3 breaths, and you need a total of 24. You really just need 21 more in order to fill up the rest of the balloon. Okay? So that's how you know. Yeah, that's what it says. She needs to double the balloon in width, which basically just means the linear scale factor is getting doubled. The volume is getting increased by a factor of 8, so 21 more breaths. All right, the next one. The radius of a cylinder is 6 inches. The height is 9 inches. What's the surface area? What's the volume? And then if the linear scale factor is 3, what's the volume of the enlarged cylinder? And then how do you know? So I'm going to use a cylinder so we can actually mark everything on here. So your cylinder is going to have a radius of 6. Okay. Can you use more? Okay. It's going to have a radius of 6. So that means, oh man, I need an expo. Where do you get an expo from? Expo! Yes. Okay. So, it's going to have a radius of 6. Okay. So this is going to have a radius of 6. We know the height of the cylinder is going to be 9. So the whole thing is going to be 9 from top to bottom. Sorry. I should probably label the whole thing, but so just so you know, okay, so that means the height is going to be 9. That's a 9, by the way. And then the radius is 6. The radius on the other side is 6. Now, the surface area just means if I lay this flat out here, then each area, when it's a flat surface, is how much, and then you put all the area pieces together. So the area of your circle up here, plus the area of your circle down here, plus this part right here. And you should get, you should be able to tell me what the area of the circle is and the area of the other circle. And then the only difficult thing is what's this piece from here to here, so that you can multiply it by 9 and get the area of this rectangular part, or the, call it body of the cylinder here. And this length from here to here actually comes from the circumference of your circle, right over here. So if you can figure out what the circumference of the circle is, if you peel it away, it should be the entire length of this part up here. And pretty sure it's like 33.1 or something like that from here to here. 0.7, sorry. So 33.7 should be the circumference of the circle. So find the area of this rectangular piece plus the area of this piece plus the area of this piece, since it's a circle, and then add them all together. That's your surface area. And your volume is, once you find the area of one of your circles, which is actually the base of your cylinder, multiply by the height. So area of one base multiplied by the height should give you your volume. Okay. Now, the next part is kind of complicated. So if the cylinder is enlarged by a linear scale factor of 3, what is the volume of the enlarged cylinder? So this actually goes with what we did today. It actually piggybacks on the third piece right here. Sorry if you can't see. Which is a linear scale factor of 1 to 3. So if we enlarged it by 3, that means the surface area ratio is going to be 1 to 9, and the volume of the ratio is going to be 1 to 27. Because 3 squared is 9, right? 3 squared is 9. 3 to the third is going to be 27. So whatever you find for the volume of the cylinder that you just did, you're going to multiply that by 27, and it should give you the volume of the enlarged figure, where the linear scale factor of 3, so the bigger cylinder. All right, that was 20. That was 20. 21. What's the surface area of the original cylinder in square feet? Remember, you're converting from square feet to square inches. So 1 foot squared is actually 144 inches squared. And if you're not sure why, it's because if you take a square and you do 12 inches by 12 inches, you get 144 inches squared. That's the area. That's how many little tiny squares you're going to have in there if it's 12 by 12. So this is the same thing as if you take a square and it's 1 foot by 1 foot, which is just same as 12 inches is the same as 1 foot, the 1 foot squared. So 1 foot squared is the same as 104 inches squared, 144 inches squared. So whatever you find, 1 foot squared over 144 feet squared, and whatever you find for your volume, what am I doing right? Oh, so the volume, sorry, that's inches. I knew something was wrong. I'm like, what? Okay, inches. Sorry. Inches squared. Whatever you found for the volume in number 20 needs to go down here, because you found it in inches, in inches squared. Your surface area, my bad. Your surface area of your cylinder from number 20. So whatever you found for the surface area of your cylinder in number 20 needs to go here. And the question is, what is it in feet squared? So you need to solve a proportion right here. You should be able to handle that. Okay, and number 22. You have, what is this? West High School. I don't even know what this is. I'm going to hide this so you can't see it. Okay, it says West High School has a math building in shape of a regular pentagon. When they measure the angle of the interior angle, then they get a polygon which measures at 135 degrees. So the question is, what type of a polygon is it? So we can check, right? So show how you got your answer. Well, let's say it's 5, right? So let's say it's a pentagon. Well, then 5 minus 2 times 180, that's going to be 3 times 180. So that's going to be equal to 540. If you divide 540 divided by 5, that's going to equal to, what is it, 108? Right? Okay, so that's a little too small. Okay, so let's try 6. 6 minus 2 times 180, right? That's 4 times 180. That's equal to 720, right? Yeah, 720. 720 divided by 5, divided by 6, because this is a 6-sided figure. Is that equal to 135? That's the question. I don't think so. Okay. You can keep on doing this, but suffice it to say, you should get 8 because it will be an 8-sided figure. 8 minus 2 times 180 divided by 8 should be 6 times 180 divided by 8 should give you 135. Okay. You should hopefully figure this out for yourself, that the only way you're going to figure this out is if you try and guess and check a little bit. All right. There probably is a faster way to do this, but if you don't know it, then it's going to be a little complicated. So, it's an 8-sided figure, and the question is, if, the ceiling is 10 feet high and the length of one side of the building is 25 feet, what is the volume of this building? Now, I love that she has a octagonal prism as a building, which is absolutely awesome, but it's a little difficult to do. So, she's saying that 25 feet is the length of one side, and we're assuming it's regular. So each side is going to be 25, 25, 25, 25, 25, 25, and then 25. Each side is 25, and the ceiling is 10 foot high, so the height, or how tall this prism is going to be, is 10 feet. So if we find the area of one base, in this case, if we find the area of this octagon, multiply by 10, we should be able to get our volume. So the octagon, right, has a thing of 25. I'm going to draw a triangle in here, and I'm going to bring it over here. Okay, it's 25. I know that it's 135 in each of these angles because that's what we did in part A. So that means I'm going to divide 135 by 2, and I should get 67.5 degrees. That's the angle down at the bottom right over here, 67.5 degrees. I'm going to drop an altitude, and that way it makes a 90-degree angle with my bottom. So I get 12.5, 12.5. I need to find the height. So this is going to be 12.5. Find the height, whatever x is, and this is 67.5 degrees. You need to use tangent. I'm going to tell you right now. And your setup should be opposite over, what is this? X over 12.5. And you should be able to get the height of the triangle. Once you get the height of the triangle, go back over here. The area of one triangle is going to be base 25 times whatever you find for your height. Goes in there, and then all of it divided by 2. Get an answer. Multiply everything by 8, because that's an 8-sided figure as your base, and then that'll give you the volume of your octagon, right? And then multiply that by 10, and you should be able to get the volume. And that's the end of that. And please don't forget, it's feet to the 3rd power when you actually find the volume of the building itself. Okay, that was up to 22, and we'll pick up with 23 in the next one.